Hey guys, welcome back to my channel. In today's video, we're going to see how to solve this problem called maximize happiness of selected children, right? So let's read the question first of all. You are given an array happiness of length n and a positive integer k. There are n children standing in a queue where ith child has happiness value happiness of I. Okay, so you want to select k children from these n children in k turns, and in each turn when you select a child, the happiness value of all the children that have not been selected till now decreases by 1. Okay, so note the happiness value cannot become negative and it gets decremented only if it is positive. Okay, to return the maximum sum of the happiness values of the selected children you can achieve by selecting k children. Okay, fine. So basically there are n children standing in a queue and we are given their happiness. So happiness of I will be telling the happiness of I children, right? So we have to pick k children from those n children, but while picking I have to make sure that whenever I am picking someone I have to decrement the happiness of all the unselected children by 1, right? So what I basically mean by that is, let's say 1, 2, 3, these all are the happiness of 3 children, right? So let's say I am picking 3, right? So I picked up 3, so 1 and 2 is unselected elements. So I will be decrementing 1 and 2. So 1 will become 0 and 2 will become 1, right? So I have picked up one child, but I have to pick one more child, right? So 0 and 1 is left, so I will pick 1 also. So 3 plus 1, that will be 4, and 4 will be the answer. So let's understand the same thing with some example. So let's say these all are the happiness, right? So these all are the happiness of how many children? N is actually 6, right? 6 children. 1, 2, 5, 3, 4, 6. And we have to pick 3 children from these 6 children. And we have to make sure one more thing, that we have to maximize the happiness, right? So what I'm saying, okay, so you have to maximize the happiness and you have to pick 3 children. So for the first guy, I'll be picking whom? I won't pick him, I won't pick him, I won't pick him. Why? Because see, I have someone with 6 happiness and I have to maximize the happiness. So I will be picking 6, right? And then the moment I picked up 6, I have to decrement all these values, the unselected values, by 1. So these will become 0, 1, 4, 2, and 3, right? So now for the second turn, I am picking whom? I will be picking 4, right? So I will be picking 4, so 4 will come here, and the moment I picked up 4, all these elements will be decremented by 1. So this will become 0, this will become 0, this will become 1, and this will become 2. Why 0? Because see, it is mentioned in the question that happiness cannot be negative. It cannot be negative. Okay, so I have picked up this element also. So I am left with 0, 1, 2, and 3. And I have to pick one more child. So I'm going to pick 3. Why? Because 3 is the maximum, right? So I will be picking the third guy as 3. So the answer will be 6 plus 4 plus 3, that is 13. Okay, so through this approach I can solve this in of n square, right? So this is the brute force approach. So what I'm doing, on each iteration I am getting the maximum of all these elements. I'm picking that element, then I'm decrementing all the other elements by 1, and then again I'm picking the maximum element, right? And again I'm picking all the other elements and I'm decrementing the value by 1, right? So I will keep on doing this until I get k children, right? But can we optimize this? Yes, so let's see how we can optimize this. So before optimizing this, let's discuss some of the intuitions that came to my mind, right? So the first intuition is, in each time we are getting the maximum value, right? Maximum value each time. So can I think something like sorting these elements? So what I am saying is that the first student should be having the maximum happiness and the last student will be having the minimum happiness, right? So I will be of course picking him, right? And then I will decrement all these values and then I will be picking him. So I'm going to sort this. The second intuition is, unselected students' happiness will be actual happiness minus number of selected students, right? So to understand this, let's have a look at this example. 7, 5, 3, 2, 1, right? So I have to take 3 students from here. So at first I have taken 7, right? So the moment I took 7, all the other elements are decremented by 1, right? And then I took 4. So the moment I took 4, all these elements are basically the actual value minus 2, right? What is this 2? This shows that I have taken 2 children. Again, in this I have taken 1. So these values will be the actual value minus 3 because I have taken 3 children, right? So now let's discuss the approach, right? So what I'm going to do, I'm going to sort this in descending order at first, right? So after sorting 1, 2, 5, 3, 4, 6 is the array and I have to pick 3 students, right? So I will first of all sort it. So, so after sorting, the first element will be the maximum, right? So I will pick him up and then I will decrement all these values by 1, right? So I have done my first move. So for the second move, I have picked up this element. So the moment I picked up this element, all the other elements will be the actual value minus 2, actual value minus 2, actual value minus 2. And then in my third move, I have picked 2. So all the other elements will be actual value minus 3, actual value minus 3, actual value minus 3, right? Now you can notice something here. 1 minus 2 is basically minus 1. But why I wrote 0 here? Here also it is basically minus 2. Here also it is minus 1. Why I have written 0? That's because in the question it is mentioned that 0 cannot be decremented. Basically happiness can never be negative, right? So we have done this. And meanwhile, I'm just adding up these elements and I'm just forming up the answer, right? So finally, answer will be 12 in this case. Can you observe this more closely? What I have done? See, we have to pick 3 children. And what I'm doing, I'm picking the first guy. So first guy minus 0 I'm picking. Why minus 0? Because till now I have picked 0 children, right? And for the next guy, I'm picking up that guy and I'm doing something like 5 minus 1. Why 1? Because I have already picked an element. That's the reason I'm decrementing the value by minus 1. Right, going forward, I'm taking the third element, that is 4 minus 2. Why 2? Because here I have taken 2 elements. So the answer will be the actual value minus 2, right? So now I want you to look at these indices and these values. So can I say something like, can I generalize this in this way? The value I am taking is ARR of I minus that index, right? Here 6 is basically in the 0th index, so 6 minus 0 I am picking up. Then 5 is basically in the first index, so 5 minus 1 I am picking up. And 4 is in the second index, so 4 minus 2 I am picking up, right? So now let's go and look at the code, right? The code is very simple and very short, right? So at first what I'm going to do, I'm going to sort this, right? So this part will be sorting this array in descending order. And then I'm going to iterate through this array called happiness. And then I'm picking the current happiness. What is the current happiness? Happiness of I, that is ARR of I minus I, right? So I will be checking whether this value is positive or not. If it is positive, go and take it. Otherwise, don't take it, right? And I will be checking for k also, because each time I am picking up some element, I will be decrementing this k by 1, right? So in total, I will be picking up k elements, right? So I will be checking for this and this k. And then I'm going to pick up that particular element. So at the end, answer will be having the summation of all those picked up children's happiness. So we are just going to return it. So coming to the time complexity of the solution, this part will be consuming n log n time, and this loop will be consuming of n time. So I can say that the time complexity will be of n log n. And what about the space complexity? We are not using any extra space, so it will be of 1. But if you consider the space that is used in the sort internally by C++, then it will be of n log n space, right? So this is done in C++ only. But at a high level, we are not using any space, so we can say that the space complexity is of 1. So that's it for the video. If you like the video, hit the like button, subscribe to my channel. Until next time, see ya.